All right. Good morning again, everybody. First, housekeeping muna tayo, ano? So, as you all know by now, na-postpone yung ating exam, yung ating face-to-face exam, which was supposed to be last Monday, ano? And we'll be doing it take-home exam na lamang, just to give time for those who were badly affected by the typhoon to go back into academic shape. And we don't want you to travel kung medyo naapektuhan kayo ng bagyo. So that's the reason why we decided not to push through with the face-to-face exam last Monday. So instead, what we'll have is a take-home exam. So I guess I announced it, tama nga ba? I'll give it to you on Friday, 5 p.m. And then you'll have to submit it via Canvas on Monday, 5 p.m. ba? Or 11:59. I think it's 11:59 p.m. So that's our agreement between or among the three lecturers, ano. So iba-iba na lang kami ng gagawing exam. It will be take home, pero for all sections, the um, the release of the exam would be on Friday 5 p.m. and then the submission is on Monday 11:59 p.m. So I hope that will give you ample time to do the exam. I haven't written your exam yet, but I'll try to do so by tomorrow. So pag-isipan ko ng mabuti. But again, take advantage of it kasi medyo mababawasan yung actually, hindi naman mababawasan yung coverage, pero ang mangyayari ay magkakaroon kayo ng more time to think about the problems because I guess the biggest difficulty for the first exam is that it's very heavy on techniques. You'll need to inspect the given ODE and then try to figure out first what would be the most efficient or the easiest method to apply to that particular problem. And then you apply that particular method, you know. Tapos, luckily, you have some days to finish it. Even if you try not to work over the weekends, you still have the whole of Monday. I'll probably make the exam doable or answerable in 3 to 5 hours para hindi kayo masyadong haggard because I also know some of you are taking math 174 and we do have an exercise on Monday so medyo magsasabay-sabay. So you might need to give up some of your weekend to the exam to do the exam. But yeah, just to give you um, a little wiggle room, ano? So hindi ko sasagadin. Siguro 3 to 5 hours yung gagawin kong exam nyo sa 151. All right? So watch out for that on Monday. Sorry, on Friday. And I'll be very strict with the deadline. So since this is already a take-home exam, I won't accept any late submission. Again, no late submissions will be accepted. So that's why don't wait until the deadline. So hindi ko tatanggapin yung mga excuse na sir nawalan kami bigla ng internet nung 11:57 p.m. All right. So I was proposing the deadline to be 5 p.m. Pero just to give some wiggle room for possible internet disconnection and stable connections, kaya ginawa naming 11:59 p.m. But again, I won't accept any late submission. All right? And we're still looking for a face-to-face exam in the pre-finals as scheduled. So please check your notes kung kailan nga ba yung schedule ng pre-fi na in-announce ko before. We'll try to stick to that schedule. Yeah, so still try to make some travel arrangements if you're not staying in LB. Now, the coverage of the exam will be until 3.5, so we still have a lot of things to do within the week because we only finished until 3.3 before the reading break. So ngayon medyo meron pa tayong dalawang sections na kailangang daanan, 3.4 and 3.5, and that would be the coverage of the midterm exam. Okay, any questions about the midterm exam? By the way, I hope you already seen my feedback on your homeworks, ano? So I think I graded everything that I received. Nasa Canvas na yung scores. For those who already submitted, I already sent you the password to the PDF files, no answer keys. So kindly review the solutions. Don't trust me 100%. I might have committed algebraic errors. If you found some, just let me know so I can edit my work. Ano? So yeah, pero if you're wondering what are the solutions to the other problems that you didn't answer, or you answer some of the problems but you didn't submit them, pwede nyo i-double check dun sa answer keys na in-upload ko. Right? So is everything clear for the exam? I hope it is. I hope, again, I apologize if there's any inconvenience due to the cancellation of the face-to-face exam. But I know majority of you are happy or thankful about the um, the um, the rescheduling of the exam and the change of mode to take home. All right. Okay, so I'm talking too much again. So simulan na natin in section 3.4. So still we are looking at some methods on how to solve general linear differential equations. Because in chapter 1, in chapter 2, medyo ad hoc yung pagsasolve natin ng mga differential equations. So most of them are linear differential equations, aside possibly from the separable differential equations. Most no nakita natin sa chapter 2 ay mga first order differential equations. And then based on how those differential equations look like, we can do solution by integrating factors. We can do some substitutions or integrating factors suggested by the form of the DE. Meron tayong exact differential equations. Meron tayong differential equations ng lahat ng components ay homogeneous. And we do have certain methods on how to solve each of those forms. Now, in chapter 3, we're looking at more generic differential equations. So mas, ano na to, titingnan natin na yung general na linear differential equation regardless of the order of the differential equation. So yun yung final goal natin dito, makahanap ng paraan para mahanap ang general solutions or particular solutions ng mga differential equations na linear, regardless of the order. Okay, and I guess in the last sections of chapter 3, we look at general theory about how the solutions of general linear differential equations are formed, ano yung itsura nila, at paano sila nakukuha base dun sa solution ng homogeneous at non-homogeneous ODE. Now, in section 3.4, we will look at some particular ways on how to write differential equations. And based on this, we can find some ad hoc solutions pa rin. All right. Specifically, this section is about differential operators. So basically, we'll start by rewriting our differential equations. At makikita natin this rewriting of the differential equations will give us an idea kung paano makahanap ng solution sa kanila, especially if the differential operators are simple enough. That is, if they have numerical coefficients alone. Okay? So in general, we define the differential operator to be the operator D to some natural number K. So pag nakakita kayo ng D to the power K, this is just our shortcut for writing the kth derivative of a function. Okay? So pag nakakita kayo ng D upper K of Y, this is basically read as the operator D to the K applied to Y. At ano yung operator na D to the power K? This is basically the kth order derivative with respect to the independent variable X. So basically, if you see D to the power K, it's an operator. It is a function applied to another function. All right? Now, shortcut lang natin siya para mas madaling isulat yung kth derivative ni y with respect to the variable x. And this simple change in notation will give us an insight paano isosolve yung ilang mga differential equations that is of general nature. Okay? Kasi nga medyo ang dami nating titingnan dito, general linear differential equations and their solutions. So it will be handy to have a shorthand notation for the derivatives, pero ang kagandahan nito, incidentally, magbibigay sila sa atin ng insights paano isolve yung mga differential equations. Okay? So this is just one other notation to put under your belts. Ano? D upper K, kth derivative lang ni y with respect to K. Bakit siya ginamit? Just a shorthand notation. Okay? Nothing fancy about it. Nothing profound about this this notation, Okay. And then based on this differential operator d to a natural number, we can define a more generic differential operator a. So see a, it is a function acting on another function y. So parang pwede niyong isipin a is a process that needs to be applied to a particular function. So si a ay tatawagin natin isang linear differential operator of order n if it looks like this. So if you have a constant a sub 0 times the operator d to the power n plus constant a1 times the operator d to the upper n minus 1 plus, there should be a plus here, dot, 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 until constant a sub n minus 1 times the operator d plus a sub n. So siya ay linear differential operator because the derivatives are in a linear fashion, are connected in a linear fashion. Walang mga derivatives ang naka-raise to another power. Remember, d to the upper n is the nth derivative. So walang power dito. So siya lang ay isang entity. D to the power n is the nth derivative of whatever function is submitted to the operator d. Tapos wala ring derivatives na nagjo-join together or nagsasama sa isang term. So hiwa-hiwalay sa mga terms yung mga derivatives of different orders. Kaya siya tinatawag natin na linear. Okay? So if y is a function of x and we apply the operator a to the function y, so pag gusto nyong computein yung ay, ang ibig sabihin lang ng ay, si operator a ay i-apply ko kay y. Okay, so that means this will just be a0 d to the power n plus a1 d to the power n minus 1 until a sub n minus 1 d plus a sub n applied to the function y. So ibig sabihin si function y ay daraan dun sa proseso ng operator a. Now if we do this, so what will happen is simply we'll have a sub 0 d to the power n applied to y. So si y, papasok lamang siya dito sa first term ng operator. So ibig sabihin, this will just be the constant a sub 0 times the nth derivative of y plus a1 n minus 1 derivative ni y plus until a sub n minus 1 times derivative ni y plus a sub n times y. So that's how you apply the linear differential operator to y. So you can imagine it as y being distributed over the sum that represents the operator a. Kaya lang iba na to. Itong dny, hindi to d to the power n times y. Kasi si d to the power n ay hindi function. Ito ay isang operator. So even though it is written as if it's a product, you interpret it as the operator d to the power n applied to y. But what is the operator d to the power n stands for? It stands for the nth derivative of the function y. And you do this for everything. Okay? So this will give us a shorthand notation to write a general linear differential equation. So pwede nating isulat itong mahabang differential process na to with a short notation. A of y lamang siya. The operator A applied to y. Okay? Does that notation make sense? Well, it is important that this makes sense kasi lahat ng gagawin natin from this point forward ay nakadepende dito sa operators. Hanggang section 3.5 yata ito. So this is a good time to ask your questions or clarifications. I hope everything is fine. Okay? Okay pa naman? All right. So this is what I'm telling you kanina. And then this will just be a more explicit representation of the application of the operator A to the given function y. All right. Now, if you have two operators A and B, it is sometimes of note to see if these two operators are equal, right? So pag meron kang operator A at operator B, and if you want to check equality between them, then you need to check, is A applied to Y gives us the same output when B is applied to Y for any Y possessing all the derivatives necessary for the operations involved. So pag pinag-prove ko kayo na ipakita nyo na operator A ay equal kay operator B, then you should get all possible functions Y that is applicable to operator A and operator B if the result of applying A to Y and B to Y are always equal, then the two operators are equal to each other. All right? So again, you can think of the operators to be processes. Equal ang dalawang processes kapag ang outputs na nakuha natin sa lahat ng posibleng inputs mula dun sa dalawang operators ay laging equal. Conversely, if you can find one function y that possesses all the derivatives necessary for the operators A and operator B, pero magkaiba yung AY at BY, then the two operators are not equal. In other words, if we can find an input Y that will give us a different output when Y is applied to A and Y is applied to B, then the two operators or the two processes are not equal to each other. Okay? So to illustrate this concept, but before that, let's define the sum of operators. So kapag meron kang operator A, a general linear differential operator A, given this way, right? Remember, ito yung general form, yeah? And then we have another linear differential operator of the same order, pero iba na yung mga constants o yung mga multipliers involved to the derivative operator, okay? Then the sum of these operators will just look like this. It's as if you're working with polynomials, ano? Para ka nag-add ng polynomials in the variable d or in the indeterminate d. So if you add a and b, you'll get a plus b equals sum of coefficients ng d to the power n. So that's what you have there. Then yung derivative operator to the power n. Then tingnan mo yung may operator, operator d to the power n minus 1. Add their constant coefficients or add their coefficients, and then copy over d to the power n minus 1. Actually, you can extend the definition of the sum to two operators having different orders. Pwede itong magkaroon ng, say, b sub n plus 1, pero siya ay order n plus 2 yung derivative. Okay lang din. Gagawin mo lang ito, mapapa-add dito sa ilalim. So, posible na magkaiba yung order. You can still sum them up, right? Imagine mo na lang na ito ay may plus 0 times d to the n plus 2. Right? So, again, addition of operators is simply like adding two polynomials in the indeterminate d. Okay? Yes, Kian, you have a question? Or wala naman? Okay. So that's how we define the sum of two operators. Now the product of two operators is a little different. So you need to be careful when dealing with the product of two operators. The product of two operators behaves more like the composition of two functions rather than the product of two polynomials. Okay? So kapag meron kang product ng operator A and B, right? And you say it's the product AB, then AB or the product AB applied to Y is equal to the operator A applied to BY. So that means the ordering here matters. Magmamatter kung sino yung una mong i-apply kay Y kaysa kung sino yung isusunod mong i-apply. And again, product of operators is not like product of polynomials, but it is like composition of functions. Because essentially, operators are functions whose domains are functions. Okay? So kaya dito, yung product AB, mas gusto ko nga siyang tawaging composition eh. A composition B or A sorry, this is B followed by A. B followed by A. Yeah, B followed by A. Because the product AB, para makuha yung product AB or makuha yung result, once you input a function y to the product AB, ang gagawin mo muna para makuha yung AB of y, okay, i-apply mo muna si B kay y, so you get by, tapos yung resulta, siya yung i-input mo kay A. That's how you compute the product of operators. We will see later that the product of two operators is not a commutative operator, or it's not a commutative operation. So may mga cases na yung AB ay hindi equal kay BA, which is in contrast to multiplication of polynomials. Okay? Kaya kailangan maging extra careful tayo sa product ng operators. Again, i-interpret nyo siya as composition. Ang A times B is more akin to A composition B. So you apply B first to your input, and then whatever the answer will go inside the operator A. So ganun natin titingnan yung product. So AB is really the operator B followed by the operator A. Apply B first, and then apply A to whatever the result in the previous operation is. Okay? So yun lang, yun yung warning para sa product ng dalawang operators. Pero sa sum, the usual thing works, okay? The usual notion of addition works. Pero dito nga medyo kakaiba to. Kasi yung product simply is, or more aptly should have been called, the composition of the two operators. Okay? All right, so let's do an exercise here. So let's consider the two operators. So we do have here two order two operators, all right? Operator A is d squared plus 2d, and operator B is d times d plus 2, or d plus 2 followed by the operator d. Remember, this is a product. So, parang composition yung aking interpretation sa kanila, right? And here, we want to show that operator A is equal to operator B, okay? So in order to prove it, we need to get an arbitrary function y, apply that function y. The only assumption on the function y is that the second derivative exists. Kasi kay operator A, kailangan natin yung second derivative because of the d squared there. And dito rin, kailangan ko rin ng second derivative. Kasi rito, if first derivative ko si d, tapos after ko siyang ma-first derivative at ma-multiply ng 2, tapos makuha yung sum ng dalawa, kukunin ko pa yung derivative niya after. So I need y to at least have two derivatives. Okay? And then i-apply ko yung a at saka si b kay y, right? And then I want to show that the two things or the two outputs will be equal to each other. And that's how I okay? So maybe I'll put that as a claim. My claim is A is equal to B. And to prove this, so I will let y be a twice differentiable function. So, na nating R na lang. Okay? Kasi wala naman sinabing domain. When I write curly D to the upper 2, ibig sabihin, ito yung set ng lahat ng real valued functions na continuous na differentiable everywhere up to the second order. So, ibig sabihin lang nito, ito yung set ng mga functions na nag-exist ang kanyang first at saka second derivatives on all intervals or on all real numbers. Okay? So, kuha lang ako ng isang random or isang arbitrary function y na ang derivative niya at saka ang second derivative niya ay nag-exist everywhere. And then what I'll do is to apply the operator a to y, all right? And by definition, this is d squared plus 2d applied to y, all right? Tapos, paano tayo nag-apply ng general linear differential operator? Well, it's as if we are doing multiplication with a polynomial d. So itong input y papasok lamang sa bawat terms ng ating operator. So I'll have here d squared y plus 2dy. Okay. Actually, you can stop here and then show that the by is also equal to d squared y plus 2dy. But if you want to see exactly how this looks like explicitly, so just remember that d squared is just the second derivative. So this is just the second derivative applied to y, or the second derivative operator applied to y. So basically, this is y double prime plus 2y prime in a more explicit fashion, right? Or you can write d squared y over dx squared plus 2 dy over dx in Leibniz notation. So those are two alternative notations. Okay? So that's the output when we input the function y to the operator a. And again, my claim here is that a is equal to b. So kailangan gawin ko ngayon, i-apply si operator b kay function y. Right? And show that hopefully the answer is also y double prime plus 2y prime. Okay, so let's do that. Let's have by. But by is a little different because b is the product of two operators. It's the product of d and d plus 2. Dalawang magkaibang operators yan. Tapos i-apply ko ito kay y. So you need to be extra careful because we don't have any theorem telling us how to multiply two operators yet. Unlike dun sa sum, meron na tayong definition o meron na tayong madaling paraan ng pagsasum ng dalawang operators. Yung definition natin ng product ng dalawang operators ay more of function composition. Kapag meron kang AB or product AB applied to the function y, i-apply mo muna si b kay y, tapos yung sagot, i-input mo kay operator A. So yun yung gagawin ko ngayon. So here, I'll apply d plus 2 first kay y, tapos yung sagot dyan, siya naman yung i-apply ko kay d. All right, so I hope this makes sense. It's as if I'm just reordering things, right? Instead of taking this product, ginroup ko muna itong dalawa na to. And basically, that's the notion of composition. I apply this one first before I apply the left operation. Okay? Now again, here, continue over here, I'll have d, tapos i-apply ko muna to. This will be dy plus 2y, right? And then I simplify this output here. This will be d of y prime. Again, d is the first derivative operator. So dy is equal to y prime plus simply 2y. Tapos, ano tong d? Derivative lang. Sabi rito, i-differentiate natin si y prime plus 2y. Differentiation rules tells us this is just dy prime plus d of 2y. So this will just be y double prime. Derivative kasi ni y prime plus derivative ni 2y, equal lang yan sa 2 times derivative ni y by the scalar multiplication rule for derivatives, okay? And this is y double prime plus 2y prime, okay? And then now we can conclude that, therefore, ay is equal to by. That is, operator A is equal to operator B. Kasi kahit ano pang function y na the differentiable twice, ay laging parehas lamang yung outputs nating makukuha, which justifies the equality between operators A and B. All right? Any questions for the solution? I hope this is clear. All good? Okay. Let's try another one. Oops. Okay. Yeah. Let's try the next example. So I have here two operators. Operator F is xd plus 2 and operator g id minus 2. And then let's see what happens if I take the product fg and compare it to the product gf. All right. So I'll consider appropriate function y, an arbitrary appropriate function y, which we will assume to possess all of the necessary derivatives so that we can simplify f times g and g times f. So, computein muna natin si fg applied to y. Okay? Again, fg, the product fg applied to y is equal to f applied to gy. Okay? Kailangan ko munang i-apply si g kay y, tapos yung sagot, siya yung i-apply ko kay f. Right? Essentially, this is f of, what is g of y? The operator g is d minus 2. So I'll have d minus 2 here applied to y. Then I'll simplify this. This would be f of dy minus 2y. But this is y prime minus 2y. Tapos, si f ay i-apply ko kay y prime minus 2y. Pero si f ay xd plus 2, i-apply ko sa kanya si y prime minus 2y. Okay? So basically, this entire function will go inside the first operator and will go inside the second operator. Okay? So ibig sabihin, this will be x d applied to y prime minus 2y plus 2 applied to y prime minus 2y. Okay? And then here we'll get what? So here we'll get x times the derivative of y prime minus 2y. So we simply apply derivative formulas to get d of y prime minus 2y. So that's going to be y double prime minus 2y prime times x kasi may x dito sa labas. Kinopya ko siya doon. Tapos ito, sinimplify ko lang. Naging y double prime minus 2y prime. Then plus 2y prime minus 4y. Then if we simplify this, this will be x y double prime minus, I'll have what? I'll have 2 minus x y prime, okay? Kasi ito ay x times negative 2y prime. So ito ay puro ano na to? Basic expressions. Wala nang operator. So the usual multiplication, addition, and arithmetical rules already apply. So I'll have minus 2xy prime para dito. Pero may plus 2y prime doon. If factor out ko lang si y prime, I'll get 2 minus, kulang pala, 2 minus 2x. Y prime, all right? Kasi ito ay minus 2x, there we go. Tapos may plus 2, there we go. So dapat ito ay plus. Tapos minus 4y. Tama ba yung simplification ko? Sana tama na. Pagpasensya nyo na, kagagaling lang ng mahabang bakasyon. So baka medyo may mga bubu dun sa arithmetic. Hopefully this is okay. And then now we will compare it to GF applied to Y and see if the two guys are equal to each other, or the two operators are equal to each other. Okay? So, pero do you agree this is the simplified form for FG applied to Y? Sana tama. Okay, thank you. Finally, may thumbs up na. All right, so let's see GF applied to Y. So again, GF applied to Y is basically first, we simplify Fy, and then whatever the input is, we will put this in, whatever the output is, we put it inside G. Okay? Pero ano ba si Fy? Si Fy ay xd plus 2. Gamit ako ng brackets para mas madaling ma-distinguish kung sino yung nasa loob at sino yung nasa labas. F is the operator xd plus 2. And I'll need to apply it to y first. Simplify ko yon, tapos kung ano yung output, siya yung ipapasok ko kay G. Essentially, this is G times G of x dy plus 2y. All right? Tapos, i-simplify ko si x dy. Si x dy ay xy prime plus 2y. Okay? Now, it's time to apply G. Ano nga ba si G? Si G ay D minus 2. So si D minus 2 ay i-apply ko kay xy prime plus 2y. So basically, so ang mangyayari, ito ipapasok ko dun sa first term, ito ipapasok ko dun sa second term, then I'll get the difference. So this is d of xy prime plus 2y minus 2 of xy prime plus 2y. Okay? And you will see here there would be a little bit of a complication. Because remember, d is the derivative operator. So the first term requires us to differentiate xy prime plus 2y with respect to the variable x. Again, d stands for d dx, right? Kukunin natin yung derivative with respect to x. E tingnan nyo yung first term. It's x times y prime. So x is a function of x, obviously. Y prime may be a function of x. So these two guys requires the product rule para makuha yung derivative niya. So i-differentiate ko si xy prime using the product rule. I get xy double prime plus y prime, okay? Plus derivative ni 2y, but that is just 2y prime, minus 2xy prime minus 4y. And then let's simplify. This is xy double prime. And then for y prime, we will have the coefficient 3 minus 2xy prime minus 4y. Tama ba? So please double check my arithmetic there. What I get is xy double prime plus quantity 3 minus 2x times y prime minus 4y. And let's compare that to fg applied to y. Remember, this is fg applied to y. And they are different from each other. Because here we do have a 2 minus 2x, but here we have 3 minus 2x. So dahil nakakita tayo ng posibilidad na magkaroon ng function y na magkaiba yung output when we first apply g, then apply y after, then applying first f first, followed by g, then we say that the product fg is not equal to the product gf. And again, that's why I really want to call this product to be the composition. Kasi alam natin composition ng dalawang functions ay hindi commutative, right? So nagmamatter sinong operation yung i-apply mo muna. Hindi laging pwedeng pagbaliktarin yan. So halimbawa, ano ba magandang example? Pwedeng example ay dryer and washing machine. Washing machine and dryer, all right? So washing and drying are your two operations, F and G. The clothes or a cloth is your input Y. So kapag pagka dryer times washing, or drying times washing, lalabahan mo muna siya, tapos i-dryer mo siya, you get a clean, dry cloth, right? Pero pag inuna mo yung drying kesa dun sa washing, so you apply drying first to your maduming damit, all right? So you get a maduming tuyong damit, kasi apply mo sa washing, so magkakaroon ka ng basang maduming damit, basang malinis na damit, all right? And the two outputs are different from each other. So parang ganoon yung operators. They are processes, all right? Hindi sila simpleng algebraic expressions, okay? So be careful. The products are not always commutative, right? But there are special cases. I'll mention when the product of two operators will be equal to each other, pero in general, they are not always equal, okay? So what's next? All right, so ito na pala. Ito na yung theorems about operators, operations involving operators, okay? First one, commutative ang addition. Pag bali-baligtarin nyo man ang addition ng dalawang operators, the result will still be the same. So no complication about addition. Kasi nga, ang definition natin ng addition ng dalawang operators ay parang nag-add ka lang ng dalawang polynomials in the indeterminate capital D, or a power of capital D. So it makes sense that addition will be commutative. Second, addition is also associative, right? The ordering doesn't matter. So hindi lamang rearrangement ng terms ang nakakapag-preserve ng sagot sa dalawang operators, pati yung grouping ay hindi nagmamatter. So I can choose the grouping of operators with respect to addition without any complication, right? And then, ganun din, associative din naman ang multiplication ng dalawang operators. So it doesn't matter if you group AB first, then C, or you group BC first, and then apply A. Ang importante ay commutativity. Walang commutative property ang operators in general, as we have seen in a counterexample that we have computed before. Pero associative siya. As long as hindi mo binabago yung ordering ng mga operators, pwede mo silang igrupo without any consequence. Alright? So basta ABC pa rin yung ordering, ABC pa rin yung ordering, kahit sino yung i-group mo, okay din. Basta wag mong pagpalit-palitin yung order nila. Alright? Now, there is a distributive property. So multiplication of operators is distributive over addition. So that means A times B plus C is AB plus AC. But again, be careful with the order. Si A ay nasa kaliwa. Alright? So ibig sabihin, if you distribute A to B plus C, dito sa original, nasa kaliwa si A, dun sa right-hand side, nasa kaliwa pa rin yung mga A's. So you simply distribute A, but not changing the order or the position of A relative to the other operators, right? So yung A times B plus C ay AB plus AC. So in contrast to say B plus C times A, again, these two guys are not necessarily equal to each other. Kasi hindi commutative ang multiplication, right? But if you do this, if you want to apply the distributive property, now you need to apply the right distributive property. So dapat si A laging nasa kanan, right? So this guy will be BA plus CA. Okay? So ito yung right distributive property. And then ito yung sinasabi ko kanina, kailan nagiging equal or ito yung exemption sa hindi pagiging commutative ng dalawang operators. If you do have two general linear differential operators A and B, then they will commute with each other, okay? Now, actually, kailangan ko pala itong i-edit ng konti. It's not for all operators. Those sa section na ito, pinag-usapan lang natin ay general linear differential operators. So, pero lagay ko na rin sa theorem para klaro. For all general linear differential operators. Dapat linear differential operators. Okay? Pag meron kang dalawang general linear differential operators na puro constant yung coefficients, then they will commute with each other. And this is the problem with the two previous examples that we have. Balikan ko yung example natin kanina, si F at saka si G. Okay? Si G, constant yung coefficients ng operator D. Meron ka ditong constant 1, tapos meron kang constant -2. So ito yung ating A0 ay 1, tapos si A1 natin ay -2. All of the coefficients are constant. However, that's not the case for the operator F. Kasi ngayon si D, meron siyang non-constant coefficient. Meron siyang coefficient na X. And you might have noticed earlier that X, that multiplier or that coefficient X caused the complication in the computation. Kasi dito, kinailangan nating mag-product rule kasi nagkaroon doon ng additional factor X. So dahil meron ditong non-constant coefficient, that caused the two operators not to commute with each other. So magkaiba si F at saka si G. However, Theorem 3.1 tells us na kapag ka constant naman yung coefficients ng iyong dalawang general linear differential operators, then you won't have any problem. Those two operators will commute with each other. Okay? And I think I have one last theorem. If you have the product of two operators, d to the power m and d to the power n, equal lang siya sa d to the power m plus n. And this is why minsan binabasa ko siya na d to the power m. Kasi meron siyang sort of uh, loss of exponents sa sinusunod. And it really makes sense because if you compute dn and apply it to y, all right, you'll do it as compute the nth derivative first of y and then compute the nth derivative after. Okay? So parang ano siya, d to the power m ng nth derivative ni n, all right? Tapos kukunin mo yung nth derivative ng nth derivative, so magkakaroon ka lang ng m plus nth derivative, which is basically d to the power m plus n. Okay? So these are some shortcuts that could be very helpful to us whenever dealing with general linear differential operators. Some of them might be familiar, So, sino nag-ano dito? Nagwa 111 right now. Show of hands. Paparecite ako kasi gusto kong uminom, kaya lang wala nga pala akong tubig na na-prepare. Kasi medyo binha kami, so yung ref namin nasa second floor pa rin hanggang ngayon. So nakakatamad kumuha ng tubig sa second floor. But anyway, yeah. Doon sa mga nagwa 111 dyan, pwede nyo i-check kung meron bang group structure o meron bang field structure ang set of all general linear differential operators. Or sabi niya, sir, wag ka nang KJ, wag mo na sa aming ipagawa yung mga gusto niyo nang kalimutan sa 111, So, but anyway, there's some algebraic structure to the set of general linear differential operators, which I will not tackle kasi kakunti pa lang yung nagwa 111 dito. At saka kakaunti na nga yung oras ko, tapos ang dami ko pang sinasabing wala sa script, But anyway, that's it. Something to look forward to, or to connect 111 with 151. Actually, marami siyang implication if you go to algebraic differential equations, but that's for a more advanced course. But let's move on. And in this exercise, you can practice with this exercise. Pero siguro I won't give you a homework this week kasi nga I'm anticipating that you need to focus all of your energy for the exam on Friday. Okay? Pero if you want to practice for that, pwede nyo tingnan itong exercises 1 to 6. Okay? So you'll simply need to perform the indicated operation. And here you need to operate on operators. Okay? But okay, so maybe I'll just leave it as an exercise. Natatempa akong magsagot ng isa, pero maybe I can go back to it later if we have some time left. Gusto kong tapusin kasi yung natitirang section 3.4 para sa Friday, makover ko yung 3.5. Pero don't worry, kaya hindi ko pa sinusulat yung exam. Gusto ko makita muna yung pacing, kung saan ako aabot ng section 3.5, Okay, any questions before we leave the general theory of general linear differential equations operators? It's quite a mouthful to say that the title, Okay, if there are none, let's move on and see. Okay, so some special applications of the differential operators. Theorem 3.4.2 tells us that if you want to take, or if you want to apply the nth derivative of e to the mx kay m to the power n times e to the m, gusto mong i-apply si d to the power n kay e to the power mx, equal lang yan kay m to the n times e to the mx. Essentially, this is telling us that the nth derivative of e to the mx ay equal lamang kay m to the power n times e to the mx. Well, the proof is simple. You can just take the derivative, because this is simply probably one thing that you have proven in math 36 already, but maybe we can revisit it. But now use the language of operators. So for this particular case, I'm going to use the principle of mathematical induction, to write a proof for this, I will do induction on n. Kasi ang claim dito, sa lahat daw ng natural number n, totoo tong statements na to. And one way to prove statements about natural numbers is to use the principle of mathematical induction. So yung proof ng mathematical induction may tatlong parte. Unang part ay yung tinatawag natin na induction step. For the induction step, we look at the smallest value of n included in the theorem. The theorem claims that this statement is true for all natural numbers n. So depende sa definition mo ng natural number kung kanino ka magsisimula. Alright? So anong smallest natural number para sa inyo? Parang ang weird ng tanong, ano? Iba-iba pala tayo ng set of natural numbers. So I guess it's more conventional to use n is equal to 1. Parang may joke nga kami dyan eh. Parang ano yung diba, sa Laguna, ano yung smallest natural number? Sa Batangas, baka iba yung smallest natural number. It depends on how you constructed the set of natural numbers. Pero usually naman, ano bang ginamit? Parang sa 101, nag-shift ako from n equals 0 at saka n equals 1 as the smallest natural number. But I usually use n equals 1 to be the smallest natural number. So sa induction step, gusto mong ipakita na yung theorem ay totoo sa smallest natural number. In this particular case, n is equal to 1. So if n is equal to 1, then we'll have the derivative of e to the power mx, all right, or d to the power 1, kasi papalitan ko lang lahat ng n na makikita ko by the smallest value of n possible. In this case, that's 1 in my convention. So this would be d to the power 1 applied to e to the mx. And I want to show that the answer is m to the 1 times e to the mx, right? But this guy, by definition, is simply the derivative with respect to x of e to the mx. Tapos magde-differentiate ka ng exponential with respect to x. So mag-ano ka lang? Mag-chain rule. Derivative ng e to the mx ay sarili niya times derivative nung exponent, right? So you learned this from Math 36. Ang derivative ng mx with respect to x ay equal lang kay m. So we'll have m to the 1 times e to the mx. So, and that completes the induction step, right? So again, the induction step is just to show that the theorem is true for the smallest possible value of n. Sorry, this is not the induction step. This is the basis step. Bakit induction step? Halatang nasa bakasyon pa ang utak, So that's the basis step, right? So showing that the statement is true for the smallest value of little n. The second part ng PMI, if you remember, is what we call the hypothesis of induction. Okay, so you'll assume that the statement is true for a particular value of k, or a particular value of n. Doesn't matter. So we will here assume that d to the power n, e to the mx ay equal kay m to the n, e to the power mx for some n in n. Okay. So yun lang. Second part, you're done. Kunwari, i-assume mo lang na totoo yung statement para sa isang specific natural number n. And then pupunta na tayo dun sa induction step, which is the third part. Sa induction step, we want to show that d to the power n plus 1 e to the mx ay equal kay m to the power n plus 1 e to the mx. So basically what I want to do in the induction step is to show that the theorem is true for n plus 1. Okay, and usually I will use the induction hypothesis or the hypothesis of induction to show this is true. Okay, so sa HOI, i-assume mo lang, kunwari totoo siya kay n. Sa induction step, kailangan mo mapakita na totoo yung statement kay n plus 1. So that's why I want to show that d to the power n plus 1 applied to e to the mx ay equal kay m to the power n plus 1 times e to the mx. And again, the reason why this is the third step is that because I want to use the hypothesis of induction in order to show this. Okay? Now, paano natin papakita na totoo yan? So, compute natin d to the power n plus 1 applied to e to the mx. Okay? But from theorem 3.4.1.6, yung huling statement dun sa first theorem natin, pwede kong i-split itong dalawa. Itong d to the power n plus 1, pwede ko itong isulat na d to the 1 times d to the power n. Or basically, I will write this first as d to the 1 plus n. Tapos i-split ko to d to the 1 followed by d to the n. Alright? Theorem 3.4.1.6. Okay? Sige, sulat ko na nga para kompleto. This is the same as d to the 1 plus n. Commutativity lamang ng natural numbers. Alright? E to the mx. And then this is d to the 1 times d to the n applied to e to the mx. Okay. And then I'll use the definition of the product of two operators. Remember, this is d1 times operator d to the power n. By definition of the product of two operators, this is just d to the 1 applied to d to the power n e to the mx. And this is where the hypothesis of induction will kick in. I already assumed in step number 2 that d to the power n of e to the mx is equal to m to the n times e to the mx. And I exactly have that here. So basically, yun yung pinaka-challenge. Yun yung crux ng induction step. Kailangan masulat mo yung nandun sa loob ng induction step in a form that will involve the terms or the expressions in the hypothesis of induction. Because you might be wondering kanina, why did I write d to the power n plus 1 as d to the 1 plus n? I could have written this as d to the n applied to d e to the mx, right? I could have done that, right? But hindi ko magagamit yung hypothesis of induction. All right? Gusto ko magamit yung nandun sa hypothesis of induction para mas madali yung proof. That's precisely the reason why you have the HOI as step number 2 first. Okay? And then now I can apply the hypothesis of induction. This will just be d to the 1, then d to the n e to the m, e to the mx, tapos ito ay i-differentiate ko lang by definition ng d to the power 1. Lagay ko lang dito by HOI para pag binalikan nyo yung notes nyo, alam nyo kung ano yung nangyari. Kasi parang nag-magic ako dito. Bakit yung d to the n napalitan ng e to the mx? Well, that's the hypothesis of induction. Okay? Now, this is just, we are now just to differentiate m to the n by times e to the mx. M to the n is a constant, right? It's a constant multiplier. Wala siyang x na involved. So lalabas siya ng derivative. Then we'll need to differentiate e to the mx. Pag differentiate niyo yung e to the mx, mag-chain rule ka uli. But we have done this in the hypothesis, in the basis step. Kita na natin yung solution dyan. Ito ay m e to the mx lamang. And this is m to the n plus 1 times e to the mx, which is basically the right-hand side that we want to show. Okay? So therefore, we can say that d to the power n of e to the mx is really equal to m to the n e to the mx by PMI. Okay? Sir, bakit nga ganun yung idea sa PMI? Kasi napakita natin na totoo siya, napakita natin na true siya for n equals 1. Tapos napakita natin with the combo of step number 2 and step number 3, pag totoo siya kay n, it will imply na totoo rin siya kay n plus 1, right? Yun yung napakita natin sa step 2 and 3. Pag totoo siya kay n, magpa-follow na totoo siya kay n plus 1. So, totoo siya kay n equals 1. So, ibig sabihin, totoo rin siya kay 1 plus 1. So, totoo siya kay 2. Dahil totoo siya kay 2, totoo siya kay n equals 3. Dahil totoo siya kay n equals 3, totoo siya kay n equals 4, totoo siya kay n equals 4, so totoo siya kay n equals 5, and so on. Essentially, totoo siya sa lahat ng natural numbers. So yun yung dahilan kung bakit nag-work yung PMI. Kasi parang kakaiba yung proof niya, no? Hindi siya deductive. Hindi, deductive siya. Pero yung appearance niya ay hindi deductive. Kasi yung title niya nga ay inductive. Pero that's the idea. Why this holds true for all natural numbers. Okay? So everything's good? Bakit kaya ako nagpo-prove ngayon? So malamang sa exam may papaprove ako, no? So watch out for that. Okay. So questions, or can I move on to the next? Right? Because I think I have so some examples, you know, if you want to apply, if you want to use the theorem, d to the 2 to the x, this will just be what? So here, we just have, ano nga yung variables natin? I have n equals 1, and I have m equals 2. So this is just what? This is just 2 e to the 2x, right? Usual derivative lang naman to. And then d squared e to the 2x, this will just be m to the power n. Remember, this is m to the power n times e to the mx. So dito ang n at saka m ay parehas equal kay 2. In example number 3, n is 3, m is 2. So that means d cube of e to the 2x. Parang nagkaroon tayo ngayon ng shortcut. Pagkuha ng higher order derivatives ng e to the power mx, this is just 2 cubed e to the 2x. Or that is 8 e to the 2x. Of course, you can double check this by doing the long differentiation process. The formula comes in very handy for problems like the 27th derivative of e to the 2x. In this case, our n is 27, our m is still 2. So the 27th derivative of e to the 2x is just 2 to the 27th. So that's m to the n of e to the mx. And that's it. Okay? So shortcut lang talaga yung theorem 3.4.2 para sa pag-differentiate ng powers ng exponential functions. Okay? Now, I guess we have another theorem. And this is basically a generalization of theorem 2. Here, kapag kasi f of d, so naghalo-halo na. Function, tapos mayroong kang operator, ano? So, but essentially, f of d means a sub 0 d to the power n plus a sub 1 d to the power n minus 1 all the way up to a sub n. So parang meron ka lang polynomial f, tapos lahat ng variables dun sa polynomial f, pinalitan mo ng derivative d. Ng derivative operator d. Okay? So yan yung f of d natin. Tapos ang sabi rito, ang f of d applied to e to the mx. Remember, f of d is not really a polynomial. It's a general linear differential operator. So the left-hand side is really read as the operator f of d applied to e to the mx. And the theorem is claiming that that is equal to e to the mx times f of m. Bakit times yung ginamit kong term? Because f of m is simply a constant. Multiplier sa exponent ni e, tapos yung constant na yun, ipa-plug in ko kay little f. So that means all these that I see here in this operator will be replaced by little m. Yun yung ibig sabihin ng f of m, right? So lahat ng operator d, papalitan ko ng constant m. So ibig sabihin si f of m really is just a constant number because it is a sub 0 times m to the n plus a sub 1 m to the n minus 1 plus until a sub n minus 1 times m plus a sub n, which is a constant. Okay? And then ang sabi ng theorem, equal daw yan sa isa't isa. Well, I don't want to spend too much time in this proof, pero essentially the idea is you appeal to theorem 3.4.2. So you start with the left-hand side f of d times e to the mx, and then you apply the operator f doon kay d. So sketch ko na lang yung proof. You can try to write a formal proof for this and double check your answer with the handout I uploaded in Canvas. So nandun yung full solution. Just to save some time, I'll just sketch what will happen. So ito, i-apply nyo to kay e to the mx. Right? Yun yung ibig sabihin nito. Operator f of d applied to e to the mx. So i-apply ko to kay e to the mx. So ibig sabihin si e to the mx ay papasok sa bawat terms dito. Right? Ganyan yung mangyayari. So essentially, you'll have a sub 0, d to the n, e to the mx, plus a sub 1, d to the n minus 1, e to the mx, plus until a sub n minus 1, d to the e to the mx, plus an. All right? And then you apply theorem 3.4.2 sa bawat isang d to some power times e to the mx. So basically, this is a sub 0. This would be m to the n ng e to the mx plus a sub 1 m to the power n minus 1 ng e to the mx plus a sub n minus 1 m e to the mx plus a sub n. This is by theorem 3.4.2. All right? So bawat isang ganito, inapplyan ko ng theorem 3.4.2. Kaya ito, naging ganito. Ito, naging ganito. And so on, hanggang sa dulo. And then I will factor out e to the mx. So if I factor out ko lang si e to the mx, I'll have a sub 0, m to the n, plus a sub 1, m to the n minus 1, until, actually hindi na pala to sketch ng proof, no? Parang pinroof ko rin siya talaga. Pero anyway, that's fine. Di pala siya ganun kahaba. Pwede ko palang ontian yung script ko, ano? Mapuprove ko siya ng mabilis. Okay? But again, here, I just factored out e to the mx and then compare this guy with this guy. Essentially, magkamukhang magkamukha ito at saka ito, yun nga lang, lahat ng capital D ay napalitan ng little m. So essentially, the second factor can be written as the function f evaluated at little m, which is essentially the claim in the theorem. Okay? And that ends the proof. Meron lang akong isang step na hindi sinulat, ano? So, which is this guy, the application e to the mx. And then dinistribute ko lang siya, nakuha ko na ito. All right? So, remember those two theorems? So, tandaan, pwede nyo siyang isulat sa papel nyo ngayon. Ano? Yung dalawang theorems, kung di nyo pa siya sa ulado. So, you can write it down in a sheet of paper because we will be using these theorems as we go along. Okay? So, sige, I'll give you a couple of maybe 15 seconds to write them down. Okay. All right. Now, what are the consequences of, or what's a nice consequence of theorem 3.4.3? Actually, theorem 3.4.3 will give us an idea on how to get some solutions to some general linear differential equations. So in what sense? Well, we'll look at the following remarks. Ano? So ang sabi ng theorem 3.4.3, ang f of d applied to e to the mx ay equal kay e to the mx times f of m. Okay? Pero ano mangyayari kapag si f of m ay equal kay 0? Now, if f of m is equal to 0, which is likely because f of m is just a polynomial in the variable m, if that is equal to 0, then f of d applied to e to the mx is also equal to 0, right? Kapag si e to the fm ay equal kay 0, ibig sabihin si e to the mx times f of m ay equal kay 0 because the second factor is equal to 0, but this guy is equal to this guy by theorem 3.4.3. So that means essentially ang f of d times e to the mx ay equal kay 0. And then that means y equals e to the mx, nakasulat na pala siya, si e to the mx ay isang solution ng f of d equals y. Because if you plug in y equals e to the mx here, yung f of d times applied to e to the mx ay magiging e to the mx times f of m equal kay 0, pero si f of m ay equal kay 0, so therefore, yung f of d applied to e to the mx is really equal to 0. Okay? So this is one general way on how to get a solution to a general linear differential equation. Kapag ka meron kang homogeneous GLDE, ng itsura ay f of d of y is equal to 0, okay? I-solve mo lang itong polynomial equation na to. Equate f of m is equal to 0. Look for the m's that will make f of m is equal to 0. And those m's, lagay mo lang siya sa coefficient to the exponent of e, then you get a solution to the ODE. Yun yung consequence ng theorem 3.4.3. Kasi kapag ka yung f of m ay naging equal kay 0, ibig sabihin si e to the mx ay solution ng f of dy equals 0. Okay? A lot of theoretical mumbo jumbo there. Maybe it would be more practical to look at a specific solution. Okay? So halimbawa, gusto nating humanap ng solutions ng d squared minus 2d minus 3 applied to y is equal to 0. So basically, if you expand this, okay, in a non-differential form, pag sinimplify niyo yung differential equation na to, you'll get y double prime minus 2y prime minus 3y equal to 0. And this is a second order linear differential equation na hindi natin kayang isolve using yung techniques natin from chapter 2, right? Kasi puro first order yung sinolve natin doon except for separable differential equations. Pero in this particular case, I can look at this as, I can let f of d to be d squared minus 2d minus 3. So essentially, this is what we're solving. Then the equation becomes f of d applied to y equal to 0. All right? So nagbago lang ako ng notations. Itong general linear differential operator, pinalitan ko lang siya ng f of d, where f is a polynomial. Then by our previous remark, if f of little m is equal to 0, then y equals e to the mx is a solution of, let's call this equation star, is an equation of star. So basically, anong tinuturo sa atin ng remark kanina? Yung pagsosolve ng general linear differential equation na polynomial yung operator or polynomial in D yung operator boils down to looking for the roots of f of m equals 0. Okay? So, kukomputing ko lang to, f of m equal kay 0. So this is m squared minus 2m minus 3 equals 0. I can try solving this polynomial equation. Basically, I can do factoring here. This is m minus 3 times m plus 1. Sana tama yung factoring ko. Tama ba? So this is m equals 3 or m equals negative 1. So this tells us that the auxiliary polynomial, so this is what I call the auxiliary polynomial. So tawagin natin siyang auxiliary polynomial. Yung roots ng auxiliary polynomial, siya yung magbibigay sa atin ng exponents kay e para makakuha ng mga specific solutions. Okay? So dahil si auxiliary polynomial m squared minus 2m minus 3, which is the exact analog of our general linear differential operator where all the operators they are replaced by m, all right, ay nagiging 0 kapag ka si m ay equal kay 3 o kaya kapag ka si m ay equal kay negative 1, then we can find at least two solutions. Then y equals e to the 3x and y equals e to the negative x are solutions to star. So, and do you see how amazing this is? Kinuha mo lang yung roots ng auxiliary equation. Nakahanap na tayo kagad ng dalawang solutions dun sa ating general linear differential equation. It's a second order differential equation, and the fascinating thing is, naging quadratic equation lang siya. Tapos yung roots ng quadratic equation na yon, ginawa ko lang coefficient dun sa exponent ni E, and ergo, I got two solutions to this equation. Now, if you don't believe me, you can replace all y's here by e to the 3x and you're going to get an identity, right? So kunin mo yung second derivative ng e to the 3x minus twice the first derivative of e to the 3x minus 3 times e to the 3x. I guarantee you, you're going to get 0. Provided tama yung factoring ko. Ano? Tama naman yung factoring ko, di ba? And then the same thing will happen if you try e to the negative x. If you replace all y's here by e to the negative x, you'll get something equal to 0 again after simplification. So that means these two guys are indeed solutions to our general linear differential equation of order 2. Now, let's pay a little some attention to details here. Look at how I phrased my conclusion. Okay, so I said here that these two functions are solutions. Nakakuha tayo ng dalawang sample solutions, e to the 3x and e to the minus x. Silang dalawa ay particular solutions doon sa ating homogeneous differential equation. I am not saying that they are the only solutions. There could be other solutions to this differential equation. Hindi lang e to the 3x at e to the negative x yung solution dito. Actually, kung babalikan niyo yung section 3.2 and 3.3, I guess we touched on how to get solutions to homogeneous differential equations. For instance, you can check that e to the 3x plus e to the negative x, the sum of these two solutions is also a solution by the superposition principle. I guess may isa tayong theorem, the superposition theorem from section 3.3 that tells us kapag meron kang dalawang solutions sa isang homogeneous differential equation, yung sum ng dalawang solutions na yon ay solutions pa rin dun sa linear differential equation. Bakit? Kasi pwede nyo i-double check ang f of d ng e to the 3x, alam natin ay equal kay 0. Ang f of d applied to e to the negative x ay equal din kay 0. Tama ba? Kasi nga sabi natin silang dalawa ay solutions. Then if we add these two equations together, I'll get f of d applied to e to the 3x plus e to the negative x equal pa rin siya kay 0. So therefore, the sum, e to the 3x plus e to the negative x, is also a solution to the differential equation. Okay? Yeah, be careful with how you write the conclusion. So I'm extra careful here. Sinabi ko lang, si e to the 3x at saka si e to the minus x ay mga solutions dito sa ating equation star. I am not saying that they are the only solutions. Sila lamang yung madaling makuha using the consequence of theorem 3.4.3. Okay? In fact, yung sum, e to the 3x plus e to the negative 2x ay isa uling solution. Okay? That happens whenever you have a homogeneous equation. Kapag ka equal kay 0 yung right-hand side, nakakuha ka ng dalawang solutions, then the sum of those two solutions are also solutions. And actually, you can go even further. Ano? Kahit anong linear combination nitong dalawang ito ay solutions din doon sa ating homogeneous differential equation. So ibig sabihin si C1 e to the 3x plus C2 e to the negative x is also a solution for any constant C1 and C2 to the homogeneous differential equation, all right? By the linear superposition property. Now, question. Yun na ba lahat ng solution? Ang general solution ba dun sa ating ODE ay C1 e to the 3x plus C2 e to the negative x? Eto na ba yung magka-capture sa lahat ng solutions? Can I call this to be the general solution for any constant C1 and C2? Yes or no? Anyone? And I'll stop here. Tandaan nyo ba? Paano pag ganun ang mga tanong ko sa exam? True or false? Meron akong equation na to. Tapos, general solution na ba niya? C1 e to the 3x plus C2 e to the negative x. Posibleng ganun yung itanong ko sa exam. Di ko lang kayo pagkakomputin. Merong mga theoretical questions. So can I say that C1 e to the 3x plus C2 e to the x is the general solution to this general linear differential equation? Yan tuloy, kinabahan kayo, no? Kasi akala nyo mag-solve lang kayo tapos biglang may mga ganitong profound questions, Well, I am not yet sure if this is indeed the general solution to this ODE. I know this is a solution, but I don't know if all of the solutions can be written in this form. Baka naman may iba pang solutions na hindi nasusulat ng ganitong paraan. Lahat ng functions na kaya nyong isulat in this form ay alam nating solution. Pero hindi tayo sure ng lahat ng equation ay nasusulat in this term. Okay? Ano yung kailangan? Para masigurado na ito na yung general equation, general solution. Ano yung requirement for us to be sure that the general solution is C1 e to the 3x plus C2 e to the negative x? Paano ko masisigurado na wala ng ibang solution dun sa ODE except those that can be written this way? Or how can I check if that statement is true? Or hindi pa kayo nagre-review? Okay, the answer, dapat linearly independent muna yung e to the 3x at saka yung e to the negative x. Remember, there's a theorem, I guess, in section 3.2 or 3.3 that tells us that if you have two linearly independent solutions, then the general solution will be the linear combination of those two linearly independent solutions. So you need to check whether e to the 3x and e to the minus x are linearly independent. And how do you check linear independence? What's the easiest way of checking linear independence? Paano pag-identification yung exam? What's the easiest way? Or the easiest way to check linear independence of a set of functions is blank. Is by computing the blank. Ano yung blank? Come on, guys. Or hindi nyo pinaghandaan yung ganong exam? Ganun pa naman ang hilig kong mga pa-exam, Well, the answer is starts with a W. Dapat alam niyo yan kasi parang iisa pa lang naman yata yung W na na-encounter natin na technical term. That W is the, come on. Wala talagang gustong sumagot. That W is the Wronskian, right? So you need to check whether the Wronskian can be non-zero for at least one x within the interval. Okay? Ganun yung pagkuha ng general solution. Because here, I don't want to make the wrong impression here. We have just found two solutions, but we are not sure if they are linearly independent. Kasi kung linearly independent itong dalawang to, meaning the Wronskian is not always equal to zero, that means linear combination ng dalawang functions na to yung general solution. But since I am not sure if they are linearly independent because we haven't computed the Wronskian yet, I don't know if all solutions will be of this form. All I know and all I am saying here ay itong dalawang to ay solutions. I don't know what the general form for the solution is. Okay? And that would be what we'll be looking at in the remainder of the chapter. Okay? So ipapakita ko na yung buong proseso. Okay? Oy, ayan, kinabahan sila dun sa exam, So, synthesize ko lang yung mga ginawa natin. But there will be a formal discussion of that as we go along in the chapter. But I hope nasisimulan nyo ng pagtagpi-tagpiin yung mga ganitong konsepto. Okay? I guess I'm over time na. Any quick questions? Any burning questions that you might have? All right, so if you're done, so thank you guys for joining me today. Apologies for the overtime, lalo na kung tatakbo pa kayo sa susunod yung klaseng physical, ano? But again, just prepare for the exam. And again, no late submissions sa exam. All right? So we'll meet on Thursday again, but until on Friday again. But until then, guys, keep safe. Bye bye.